Atoms are the building blocks of everything around us. They form the foundation of all matter, from the tiniest grain of sand to the largest mountain. Without atoms, nothing would exist. They are the smallest unit of an element that still has the chemical properties of that element. Each atom consists of a nucleus surrounded by electrons, and this structure gives each element its unique characteristics. Imagine a brick house. The bricks are the atoms, and the house is the larger object made up of many atoms. Atoms are incredibly small, so small that millions of them could fit on the head of a pin. You can't even see them with a regular microscope. Special tools like electron microscopes are needed to observe these tiny particles. Everything we see, touch, and taste is made up of atoms. From the chair you sit on to the food you eat, atoms are everywhere. From the air we breathe to the food we eat, it all comes down to these tiny particles. Even the water we drink is made up of atoms bonded together. Atoms are important because they determine how matter behaves. The way atoms are arranged and how they interact with each other can change the properties of a substance. The way atoms interact with each other determines whether something is a solid, a liquid, or a gas. This interaction is what makes the world around us so diverse and fascinating. Atoms themselves are made up of even smaller particles called protons, neutrons, and electrons. These subatomic particles are the fundamental building blocks of matter. Think of the atom like a tiny solar system, where each part has a specific role and place. In the center of the atom is the nucleus, which is like the sun, holding everything together with its strong force. The nucleus is made up of protons and neutrons tightly packed together. Protons have a positive charge which contributes to the overall charge of the nucleus, and neutrons have no charge, making them neutral particles. Whizzing around the nucleus are the electrons, which move at incredibly high speeds. Electrons are much smaller than protons and neutrons, almost 1,800 times smaller in mass, and they have a negative charge, balancing the positive charge of the protons. The electrons orbit the nucleus like planets orbiting the sun, creating a dynamic and balanced system. The number of protons in an atom determines what element it is, defining its unique properties. For example, all carbon atoms have 6 protons, which is why they are all classified as carbon. The number of neutrons can vary, which creates different isotopes of the same element, each with slightly different properties. Atoms are essential for life as we know it. They form the molecules that make up our DNA, our cells, and all living organisms. Atoms also play a crucial role in many everyday processes, like burning fuel and cooking food. The study of atoms, called chemistry, has led to countless discoveries and inventions. From new medicines to more efficient energy sources, understanding atoms has helped us make incredible progress in many fields. The idea of atoms has been around for centuries, dating back to ancient civilizations. Ancient Greek philosophers such as Democritus and Leucippus first proposed that matter might be made up of tiny, indivisible particles called atomos, meaning uncuttable. However, it wasn't until the 19th and 20th centuries that scientists developed a more complete understanding of atoms, thanks to advancements in experimental techniques and scientific equipment. Scientists like John Dalton, J.J. Thomson, and Ernest Rutherford conducted groundbreaking experiments that revealed the structure of the atom, leading to significant breakthroughs in the field of atomic theory. They discovered the existence of protons, neutrons, and electrons, which are the fundamental particles that make up an atom. Through their research, they developed various models to explain how these particles interact and form the basis of all matter. Today, our understanding of atoms continues to evolve as scientists make new discoveries and develop new technologies to study these fundamental building blocks of matter, pushing the boundaries of what we know about the universe.